Good afternoon, everyone. So today we are here for live session 2 of thermal processing of foods. So we had been discussing many things in the discussion forum. So I couldn't see much of you joined this live session. So the questions what I get is to solve the problems, whatever we had given in the assignment. So accordingly, we had solved the problems which are given in assignment 1, 2, and 3 in last live session. So for your reference, and today we are going to solve assignment 4, 5, 6. So whatever the problems given. So otherwise theory questions, most of you are doing it correctly. So that will be separately uploaded. The answers to those theory questions will be separately uploaded. So we will solve those two problems. In assignment 4, we have one problem questions, that is computational question. And then assignment 5 also we had one problem to be solved to get the answer, right? So these two we will see in today's session. And then if some of you join or if you have any doubts, you can join and post. Screen is visible to PowerPoint. So in assignment 4, we had asked a question. We had given D and Z values at 90 degree. So this is a temperature, processing temperature. So the D value is 0.53 minute and Z value is 7 degree. Right. So as I said in the lecture, your unit is very much important, right? So D is given in time unit, which is minute, and Z is given in temperature unit, which is degree centigrade. And then you were asked to find what should be the D value at 100 degree centigrade, but you were asked to calculate that in seconds, right? So you should know the difference. Sometimes when you calculate, you do mistake. So you were asked to find out in second. So you very well know the relation, right? So if you are given D value and Z value at reference temperature, how to find out D value at the other temperature, DT value, right? So what is the formula? Log of T2 upon D1, which is equivalent to T1 minus T2 upon Z, right? So what is your T1, D1, and then Z? Z is not depend on temperature, only D value changes. So T1 is 90 degree. So for that 5.53 minute is given. And then you are asked to find 100 degree in seconds. So you convert this 0.53 minute into seconds, which is 0.53 into 60. 60 seconds is 1 minute. So this manipulation you did. And then now you coming back to D2, which is unknown to you, or you can put it as this is T2, D2. So D2 is not known to you. So D2, or you can put it as D at 100 upon D at 90, which is equivalent to what is D1? D1 is 90, D2 is 100 divided by Z values given 7. You calculate and then this you will get as a value. This is log of this. And then if you want to have D at 100, so you multiply this D90 and then 90 minus 100 upon 7. So this you need to be careful, 0.53 into 60. And also remember this particular thing you have done in log, right? So because of when you are taking 10 to the power by both sides, then log get it cancelled. So then this will be at 10 to the power of this one, right? So you calculate 10 to the power of 90 minus 100 upon 7 and then multiply with 0.53 into 60, then you will get a, right? So that is the d value at 100 degree. So this is assignment 4 problem. Then we had a assignment 5. So in that, the problem given is based on heat penetration test. Right. So in that, it was told that we had used inoculation test. We had used inoculation, we had used Clostridium sporogenous for an inoculation test, right? For the d value is given at 121.1 degree centigrade. It is 1.2 minute, and the concentration is 10 to the power of 7 per gram, right? And then we were told that we have a canned food of 500 grams, right? And we supposed to find out what is the maximum process value, right? That can be measured with using this force, right? And there is another assumption given, which is nothing but the limit for spore numbers at the end of the process is unity. So that means final number of spores come to be a 1, right? So the problem is heat penetration test. I'm using Clostridium sporogenous for inoculation test, which has the d value of 1.2 minute, and its concentration is given as 10 to the power of 7 per gram. So I'm using that to do the test in a canned food of 500 gram. So what should be the maximum process value that can be measured using this force, right? So the formula is very familiar to you by now. So that is d into st, right? So this we had told us log n naught upon n. So n is also directly given, that is 1, and d also directly given, that is 1.2. So the only difference is how to find out n naught, right? So here, whatever you are using has 10 to the power of 7 per gram, but you are diluting that into 500 grams of your canned food. So you need to convert this dilution, right? So 10 to the power of 7 upon 500. Or you can put it like 10 to the power of 7, 5 into 10 to the power of 2. So then it is 10 to the power of 5 upon 1 by 5. So this is 0.2 into 10 to the power of 5. So or you can put it as probably 20,000. You please check this number. So then you will find out here. So log of 20,000 upon 2 and then d value. D value is given as 1.2 minute and then f value is asked. So this is the way you find f for this particular problem. So formula is known to you just to make sure that you learn the concept of dilution. This problem was given. So apart from that, assignment 6 did not have any problems as such. Those were theory questions. So that had asked based on the lecture, whatever you had already. Okay, so this is the week we have uploaded assignment 7. So the assignment 7, 8, 9, we will see in next live session. Okay, so if We will wait for 5 more minutes. So if you have any doubts or any of you join, otherwise we might end it. And this particular recording will be available in your course site. Then you can refer it later. Otherwise, as usual, we will discuss in the discussion forum if you have any further doubts. Okay, so the same recording is available on your course website. So if you have any doubts, you can always post it in forum or discussion forum. Thank you very much.